Hi guys, today we're going to be solving a radical equation or solving an equation that contains radicals. Here's our example. This is a fairly complicated one because uh, we have a variable outside of the radical and inside. So these are the more complicated types of problems you'll see of radical equations. Only complicated because it involves several steps. Each step itself is not terribly difficult, and it's things that we've done before, but just remembering the order of the steps is probably the most challenging part of this problem. So step one is to isolate the radical. We want to concentrate on removing this radical from the equation because once we do, we'll just be left with x terms and numbers, which is something that we know how to solve, hopefully. So that's always our first step, is to try to remove that. And in order to do that, we need to isolate it on one side of the equation and move all the others on the other side, because we're going to square both sides. And when we square a radical or a square root, the square and the square root cancel, and we're just left with what's inside, or the radicand of the radical. So we square both sides. We have to put all of the terms on the left side in parentheses because we're squaring that entire left side, and we have to remember that x minus 3 in parentheses squared means x minus 3 times x minus 3. So we're going to have to FOIL this out, or if you know the binomial square pattern, you can just skip to that part. But I'm going to go ahead and FOIL this out just to emphasize that we do need to take x minus 3 times x minus 3 in parentheses. Again, our radical and our square canceled out, so we're just left with 27 minus 3x on the right side. So squaring out the left side, we get x squared minus 3x plus 9 equals 27 minus 3x. So our next goal is to combine like terms and bring all of the terms to one side. I generally pick the side that has the x squared term as a positive term, so I'm going to be moving everything to the left. So minus 3x is minus 6x. Now we need to subtract 27 from both sides. That'll leave us a minus 18 on the left, and then we will add 3x to both sides to bring this x term over. That leaves us with x squared minus 3x minus 18 equals 0. Well, why did we do that? Well, we're going to be factoring the left side, and these problems are set up so that when you move every term to the left side and you have 0 on the right, that this trinomial can be factored. So in this case, it does factor to x minus 6 times x plus 3. If your trinomial here can't be factored, it probably means you made a mistake. So you would go back and see if you didn't FOIL something correctly, or you missed a term or a minus sign or something like that, because these always should factor at this point. So we did this so that we can use our principle of zero products to obtain two solutions. We've got the situation of something times something equals 0. That means that one of these two things must be 0 in order for that to be true. So either x minus 6 is equal to 0 or x plus 3 is equal to 0. Add 6 to both sides here, subtract 3 from both sides here, and we get our two possible solutions, x equals 6 or x equals negative 3. Last step is very important. It's the one that is most often forgotten. We have to check our solutions into the original problem. So I'm going to check x equals 6, plug it in everywhere where we see an x in the original. I get 6 equals the square root of 27 minus 3 times 6, and then a plus 3 outside of the square root. Doing a little simplifying here, we get 27 minus 18 inside of the square root, which is 9, and the square root of 9 is 3. So we get 6 equals 3 plus 3. That is true. Therefore, x equals 6 is a solution to our equation. Our other is x equals negative 3. Plugging that in everywhere we see an x, we get negative 3 equals 27 plus 9 inside the square root, which is 36. Square root of 36 is 6, and we're left with negative 3 equals 6 plus 3, and that is false. So we say that our solution is only the solution x equals 6, and the solution x equals negative 3, we call it an extraneous solution, and we throw it out or disregard it because it is not an actual solution of the original. So always check both of your possible solutions. It's possible that both are solutions. It's possible that one is and one is not, and it's possible that both are extraneous and that the original equation has no solutions. So just because you get one that works doesn't mean that your second one is going to be extraneous. You always have to check both. Okay, that's all for today.